Machine learning, deep learning, artificial intelligence. It's all the same thing. Actually, not quite. So, deep learning is a subset of machine learning, which is a subset of artificial intelligence. Inception much. Anyway, that is basically how things are structured. Artificial intelligence, machine learning, and then deep learning. But let's start from the top so we can understand this entire tree of knowledge that I'm providing to you, and you're giving back by clicking on the like button. Much appreciated, and welcome aboard. This is the Computer Programming University. All machine learning is AI, but not all AI is machine learning. But what is AI? What is artificial intelligence? AI essentially deals with, in computer science, the smart of the computers. Basically, we're talking about allowing computers to exhibit behaviors which we associate with human intelligence and human behavior itself. So rather than just repeating a set of tasks that we've programmed the computer to do, the idea of the computer going above and beyond the sum of its parts, essentially being smart.
The goal of AI is to create systems that can function intelligently and independently. Humans can speak and listen to communicate through language. This is the field of speech recognition. Much of speech recognition is statistically based, hence it's called statistical learning. Humans can write and read text in a language. This is the field of NLP, or natural language processing. Humans can see with their eyes and process what they see. This is the field of computer vision. Computer vision falls under the symbolic way for computers to process information. Recently, there's been another way, which I'll come to later. Humans recognize the scene around them through their eyes, which create images of that world. This field of image processing, which even though is not directly related to AI, is required for computer vision. Humans can understand their environment and move around fluidly. This is the field of robotics. Humans have the ability to see patterns, such as grouping of like objects. This is the field of pattern recognition. Machines are even better at pattern recognition because they can use more data and dimensions of data.
So when we think about AI, we think about, for example, imagine on its most simplest terms, imagine a program that asks the user questions and provides feedback to the user as well, similar to the way a human would interact with that end user. So imagine a standard program that does not incorporate artificial intelligence. It may ask you, what is your name? And then you give it your name and it would just enter it. And then it would ask you another question and then it would just enter it. Really not really doing anything smart, just basic data entry. Now, with artificial intelligence, the application might ask you what your name is, and then when you give your name, it may say something like, "Hello, Frank, how are you doing today?" Or perhaps it may make a comment about your name. "That's an interesting name. It sounds French. Are you from French? Are you from France? Are you from French?" Wow, that's a bad program if it does that. So basically what we're talking about is simulating a human conversational tone. So rather than just being digital, ask for information, store information, ask for information, store information, we add the element of friendliness or small talk, things that we associate with human behavior. Think about a program that also will sit on your computer and analyze your behavior and come up with ideas that it might alert you to. For example, imagine a program that sits in the background, and while you're using your computer, it analyzes certain patterns. And one day it may say to you, hey Frank, I've noticed that a lot of times you tend to edit video when you have a lot of applications in the background that are taking up a lot of memory, which leads to your video editing application running slowly. So you might want to shut down those applications before you start editing to avoid the problems that I'm seeing you running into. See, that's artificial intelligence. You've taken the initiative to sit there and analyze this behavior, the user activity, and you're looking at things in context. The user is doing a particular task. That task is being compromised by something else that the user is doing. So you're able to put all of this data in context and then respond to it by simply giving the user suggestions. Now that's not something that a program would normally do without artificial intelligence, because normal programs, they're just sort of, they only do what they're told to do. They don't generally make an assessment. So in short, it's just making programs smart or exhibit human-like behavior. So that's a very broad and general term when we say artificial intelligence. Now, under artificial intelligence, there's lots of strategies and technologies and methods at which we use to employ artificial intelligence in our applications. So we want this human-like behavior, but how are we going to go about achieving that? What methods and strategies and technology are we going to utilize for that end result of this AI type of experience? So with that in mind, one of the methods or strategies is machine learning. So with machine learning, as the name suggests, is a process at which you can have an application actually seem to learn. So you can train the application with the initial data that you provide to it. For example, let's say that you have created a home assistant type of application, which is temperature aware and relevant or appropriate outfit for the temperature aware as well. So for example, the way you could train this application, and just to be clear what the purpose is, this particular function that it does. So it's going to suggest you an outfit to wear that is appropriate for the conditions based on the weather, right? So you would need to first train this application. So you could train it by basically giving it some scenarios. So today it's 80 degrees and you can look at a bunch of outfits, right? And you can say, t-shirt and shorts, good. And go through a series of outfits that are appropriate for the weather. And you're like, that's good, that's good, that's good. Then you say, winter coat, not good. Leather jacket, not good. Hoodie, not good, right? So that's for one temperature. Then you go different temperatures, different types of weather conditions. Maybe it's raining, right? So you give it this initial data. So that's the training of the deep learning, or rather the machine learning application, right? Then the learning, or I guess that's learning as well. That's the initial learning or training, right? But most of the learning with machine learning will come from the ability of the application to learn from new data. So I've given you the initial data to analyze and to sort of pattern recognize. So you're looking for patterns. As the temperature gets higher, the outfits get smaller and thinner and more breathable. As it gets colder, the opposite happens. So now you have a new temperature, 75 degrees. You weren't trained on 75 degrees. You were only trained on 80 degrees and 60 degrees. So now the application needs to sort of extrapolate what's an appropriate outfit for those types of conditions. So it looks at the previous data, outfits that are appropriate for 80, outfits that are appropriate for 60, and then tries to find a middle ground. What if you have an extreme temperature scenario? Maybe it's 32 below zero, right? The pattern from the initial training could have indicated that you add layers. First of all, you use certain types of clothing, certain types of material, and the machine learning application could identify that as the temperature gets lower, one key strategy beyond the types of clothing and materials is the addition of layers. So it could extrapolate that the coldest temperature that was used in training was, say, 32 degrees, and at that point the layers were at the highest amount, so it was at, like, let's say 3 layers. Now you're at a temperature that is twice as cold or something like that, so it might suggest 6 layers, right? Now we could get into the idea that there, rather than just simply adding more layers, there could be extreme weather type of gear that would be better suggested, but that's a whole nother conversation. The bottom line is, even if the outfit might not be the most appropriate because the application is not quote unquote smart enough, it could easily use deep learning techniques to be able to sort of extrapolate that, hey, maybe a 6-layer outfit would be adequate. So it picks from its winter gear, so winter gear, winter type of clothing, and then it utilizes an argument or an element that is utilized for colder and colder temperatures, which is layers. So just multiply the layers by a higher amount, for example. So that's, I think, one of the core concepts of machine learning, where the application is able to learn on its own without human interaction, right? You set it up with the initial training data and then you let it run, and it can sort of figure things out on its own based on the sort of template that you've given it. So with deep learning, the application can learn features and tasks directly from the data, and the data can be in the form of images or sound or text. So when we talk about deep learning, we're talking about a specific strategy of having an application be able to learn or figure things out on its own. So for example, image recognition. So I could create an application that is able to identify certain, and let's say you have a deer problem, right? And you have some kind of countermeasure that will scare the deer away. So you need the application to be able to recognize what a deer looks like to be able to trigger the countermeasure, correct? So with deep learning, and in order to accomplish this task, you have training data that you would start with. So you want to have, let's say, a group of images, which is your training data, and you label these images as deer. So these are all deer, right? Here's a picture of a deer, here's a picture of a deer, here's a picture of a deer, right? And then the deep learning application will then take that data and learn the features of the data in terms of, this is what a deer looks like, color, contrast, shapes, all these kinds of things. And then there's finally the classification part of the process. Now, to do this, they utilize what's called a neural network, which vaguely mimics the human brain in terms of the way that we think. Now, the amount of layers that the application goes through to actually be able to classify and identify features and everything that it's designed to do can be vast. And therein comes the term deep learning. And now for some additional details on what deep learning is, let's listen to someone who knows a lot more than I do about deep learning.
Most deep learning methods use neural network architectures. This is why you often hear deep learning models referred to as deep neural networks. One popular type of deep neural network is known as a convolutional neural network. A CNN is especially well suited for working with image data. The term deep usually refers to the number of hidden layers in the neural network. While traditional neural networks only contain 2 or 3 hidden layers, some of the recent deep networks have as many as 150 layers. So now that you understand these key deep learning concepts, here are a few examples you can try with MATLAB. Recognizing or classifying objects into categories, as seen here, where a deep network classifies objects on my desk. Detecting or locating objects of interest in an image. like in this example, where we use deep learning to detect a stop sign. To find out more, you can visit our website at mathworks.com/deep.